still waiting for one jury member, so there will be slight of a delay. But I think all the teams are ready. So just to explain the rules shortly, you have basically only 4 minutes to present your pitch. After 3 minutes, I will raise my hand so you know that you need to wrap up a little. And then after 4 minutes, unfortunately, I need to cut you off. So yeah, basically, this is it. And then we will move to the jury discussion and questions. Also, welcome to ask questions if you want. And there will last around 10 minutes. Yeah.
From minor symptoms like tingling in the hands and feet to a very severe one like feeling suicidal. These are symptoms common among over 500,000 of patients from acute kidney injury or AKI in the UK. AKI affects a huge number of population, especially in the intensive care unit or ICU. So if you take a closer look in England, we can see that out of 250,000 of people who get admitted to ICU every year, more than 50% of them get diagnosed with AKI. So despite it being detectable and preventable, still 30% of them doesn't survive until the 7th days. This results in a treatment cost of £1.02 billion per year. The problem lies in the current creatinine monitoring system in the ICU, because first, it is expensive. According to our interview with nephrologists, an ideal monitoring can cost up to £500 per week per patient. It is also time-consuming, as one lab test can take up to 3 hours for the result to be analyzed. And lastly, the data gap can occur since some hospital can only conduct 1 to 2 tests per day only. So that's why we introduced AMI, an acute kidney injury monitoring system for intensive care unit. AMI is continuous. It can measure creatinine hourly for 10 days consecutively. It is almost 30 times cheaper than the normal serum creatinine blood test performed in hospitals. And also is designed to be small and compact like this, suitable for ICU settings.
To make AMI come to life, we will take the help of these key stakeholders who will be part of our journey, starting with seeking fundings to develop an MVP. Nephrologists, nurses, and patients will be part of our interviews to develop an ideal product for them. We will then move on to acquiring regulatory approvals, including the CE, UKCA mark, EU MDR, and UK MDR, with the help of regulatory bodies and notified bodies. This will be done through clinical studies, which will start in Glasgow, our local place. This will be done in hospitals, including the Queen Elizabeth University Hospital and the Royal Infirmary, which we've already had close contact to, and we've done our research on them. We will then have our utility patent granted. This will then allow us to move on to our next step, which is clinical trials, through which we will increase our credibility, and then to increase visibility to companies, we will get the help of researchers at the University of Glasgow to attend academic conferences as well as trade shows to showcase our sensor. Moving on to our final step and most important one, we will license out AMI to our most important stakeholders, the licensees, who are the diagnostic healthcare companies. These are our milestones. We've already started seeking funding, and we've achieved the interest of Diagnostic Healthcare, who are a local company in the UK. And we've also gone through the second stage of Santander X, which is a competition for entrepreneurs from university societies. By March 2028, we'll have acquired regulatory approvals through small-scale production and to have our utility patent granted by September 2028. We will then move on to increasing visibility through marketing strategies to license out AMI by September 2030. Our licensees will have the following market size, starting with £22 million in Europe only. With more than 1 million patients in Europe only, we will have a penetration rate of 90% and a cost per unit of only £24. The licensees market can go up to more than £216 million per year, with a total available market of 10 million patients.
Sorry, the time is up, so just one sentence.
Just one sentence. This is our revenue model, and we break even in the 6th year. Thanks for listening, and go Glasgow.
Okay, thanks a lot, Team Klaus, Sens, for your presentation. Let's have a look at if some of the jury members have a question to kick off with. Anyone that would like to start? You would like? Okay,
Yeah.
thanks.
Thank you for your presentation.
Thank you.
I didn't have the opportunity to read your TRD before seeing your pitch. What is the main patient that you will be targeting? Is it like any patient with acute kidney injury, or are you specific use group?
So we specified the ICU patients because these are the very critical patients whose creatinine levels are monitored. Ideally, it should be monitored 24 hours a day, so every hour, but it's currently not being done so. So that's what we are aiming for.
Okay, thank you.
And also because they are those who are most in need of the product. So therefore, the product will be much more utilized and beneficial for them. So that's why.
All right. Thank you very much for your kind presentation. I have a question regarding your business model. In your TRD, you also described it in detail, how you want to do it with a licensing approach. However, at least when I was reading it, what I found a little weak spot, you are focusing on licensing, clear strategy, but you give little information on IP, and especially if you're going for a licensing, let's say, business model, it's crucial to have IP. So in this respect, did you scan for potentially conflicting IP of other competitors?
So currently, we haven't protected our IP because we're using proven technologies like MIPS and ultrasound, but we'll then what we'll license or what we will have protected is our whole product, which is a combination of all of those technologies, and we've already talked to IP specialists, and that's the plan.
Okay, just because especially if you are going for licensing and let's say you find a big company and they like your product and it's no IP protection, they might just take over the idea and say thank you, but might not reward you too much. No? So just make sure that you find some component. Either you keep some IP for yourself, because maybe you have a specific algorithm or something which they cannot trace back. Otherwise, it might be a challenge here.
Yes, I understand. Thank you.
Another question that I have is also when it comes to the partners that you want to work with. I was missing a little bit an explanation. How do you create an incentive for them to work with you? So what is the win-win situation that they create?
So this could be explained through our revenue model. So we're just assuming a revenue model for our licensees where they make, this is starting in the UK, starting locally, they could make up to, they could break even, in the 4th year, we're making almost £13,000. But this is assuming it's a startup, a small company, but big companies like Abbott or Roche, it would be very much easier for them as they already have the marketing channels, manufacturing costs, and all of that already in place. So for them, it will be an easy task.
So another key points that we believe that our business is quite attractive is that we will undergo the clinical studies already and clinical trials, so they don't have to worry about getting CE, EU MDR, stuff like that. Yes.
Also, there's another point that we can actually attract partners. It's actually the novelty of the approach. And something else which is very important, the flexibility of it. So it can be extended beyond creatinine to develop MIPS for detecting other biomarkers. So therefore, it will provide them with the potential of accessing novel markets as well.
All right, thank you very much.
Thank you.
How do you plan to scale your production as the demand increased? And and what strategy are in place to manage the cost fluctuations, and especially in the raw materials and manufacturing? So
All right. So to answer the first question, how to scale up, I just want to mention again that our business model is not to manufacture it ourselves, but we're gonna sell our IPs, license our IP to manufacturer companies. So like biosensor manufacturer that they already have the resources, the factories, and they'll have a market, the resources available for them already, and it will come at a lower cost. So yeah, that won't be our problem. Yeah. Does that answer your questions?
I have a question also following upon Milan's question. You have this clear focus on ICU patients, and I think at one point you showed this slide with the screening process. We kind of decide, is there a risk of developing AQ, yes or no? So that's before the sensor comes in, right? And how would you decide which ICU patients are at risk? Are there clear policies already in place or indicators that one can use?
Yeah, so this is based on NHS England, the risk of AKI. So patient in the ICU that's age 65 or older are really prone to get AKI in the ICU. And also those with kidney transplant, heart diseases, or undergo like long-time medications, these are all patients at risk. So we suggest, we can decide for the doctors, that's for sure, but we suggest that our sensors will be very beneficial if it's applied at the very start of the process, the screening process.
Okay. So, and what percentage are we talking about in terms of patients entering ICU that then would end up being monitored by your device?
You mean the first?
Yeah.
slide?
First risk of AKI. That's
Yes.
the first step, and then you said, okay, we have a couple of patient groups in mind that are more likely to develop AKI, and those are the ones we will put on our monitor.
Yes.
Percentage-wise, can you put a number? You have an idea?
Well, 50% of the ICU patients.
Okay. Yeah, and then also for me to understand a bit. So the moment they have a high risk, you put them on monitoring for the duration they're in the ICU. That's your testing model.
Yes.
And the entire duration of measuring is covered by your unit price of, what was it, 24?
24 pounds.
Okay, so it doesn't require like new patches every now and then, or it's that's the price for the entire solution. Okay.
It's only changeable after 10 days.
Okay, and that's typically by then they have
exactly.
left the ICU unit.
AKI patients only stay in the ICU for 7 days, a maximum of 7 days. After that, it's something else, not AKI.
Thanks. Any other questions? Any questions from the audience, perhaps? No, I'm not sure how we're doing in time. 2 minutes left. Then I want to go back to your first slide where you talked about the expected cost savings you can realize at hospital level by entering your solution. Did you do a break-even analysis from their point of view? So knowing how many patients would they have to have on your device to start realizing those cost savings? And would it affect the size of hospital that is needed, or it can become profitable quite quickly, I assume?
Yes, so we're starting with assuming only 750 sensors are sold per year. This is a very small number, of course.
But that's your break-even point, right?
No, that's the
okay,
licensing.
okay, then I got it wrong during the presentation, sorry. Okay, sorry about not clear enough.
So for the licensing company, they break even at the 4th years, but us as GlassSense, we will break even at around 6 years.
Okay.
Yes.
Okay, that clarifies it. I give you the mic.
So would the hospital then be a licensee, or?
Yeah, so the licensing company will be those who can manufacture our sensors. So company like diagnostic company, biosensor, medical device companies.
Okay, but so what's in it for the hospital? When's the break-even point for the hospital?
So this is tough questions as it depends on the country. Each country has different healthcare systems. So the hospital in the UK, they relies on one system, which is the NHS, the National Health System. Yeah, so it is depend on whether NHS decide, and the local hospital will likely be deciding based on the NHS decision anyway. Yeah.
And the NHS already has partnerships in place with diagnostic companies like Abbott, for example, for glucose monitors. So we are expecting something similar for this sensor as well.
Okay, thank you guys. Yeah, and I would like to welcome biosensing team to enter. There you go,
Yeah,
Mike,
thank you.
and the clicker.
I'm starting. Yes. Hello. Good afternoon, everyone. We're Xavi and Dan, representing Biosensing Team 20. And today we're going to be showing you the translational potential of our device, AkiSense. We're going to target ICU patients that have undergone a major surgery in the US. These make up for around 5% of the total cases, which is around 300,000 patients every year that are at risk of developing this condition. We chose the US because of the regulatory structures that make it easier to cover the whole country at once, and because of the investment ecosystem. Our solution will help hospitals, which will be our main customers, to discharge patients earlier from the ICU without compromising the healthcare quality and at a minimal discomfort, since we plan to bring this actual device to a patch-sized system. Hospitals, clinical trials, and insurance companies will be based in the US. They will be reached through connections with the university and the TechMed Center, which is internationally known. And we've also developed this network of companies in the R&D industry in the medical device industry, and also hospitals in the Netherlands and in Spain. The key insights that we gather from all the interviews that we performed is that creatinine can be used for at-home monitoring, given that we use the correct intellectual property strategy.
Now, our early-to-market entry to keep us afloat during the each years of development is done through licensing. We will focus on having a single strong patent that goes over our sensor technology and how it is integrated into the device. We will go for a stage-specific and non-exclusive model, allowing us to better mitigate risks and target multiple partners, bringing in additional revenue. In addition to using our technology as a platform, targeting different diseases and biomarkers. Then our mature business strategy focuses primarily on a service fee-based model, whereby we offer premium features for a premium membership. Secondly, our royalty agreement system will focus, as explained, on the licensees. And last but not least, through data monetization, which we will sell the data which we gather under ethical guidelines to government institutions and other health tech companies of interest. Our 10-year timeline then for development focuses on 3 stages. The first on building up the company itself, the second getting the product to a market-ready stage, and the third launching and looking at future growth opportunities. As you can see, there are 2 funding rounds predicted, whereby we try to gather 6.5 million through a seed funding approach. This will be divided up among subsidies, grants, venture capital, loans, and investor relations. Our financial timeline then predicts that the break-even point of this venture will occur during the 8th year, where revenue will overcome expenses. Of course, all of this will be driven by the force of our lovely team. We're multidisciplinary and highly international, although we cannot cover all the areas which we will need. This will be done through expertise and collaborations with business marketing, legal, and research orientation groups, which we have already engaged with and can be found on our campus. Last but not least, stakeholder input will be used for validation and verification of our design choices and will be targeted through patients, hospitals, and other researchers. Now, we would like to offer you the opportunity to join us on this venture and revolutionize the AKI diagnostic world. What we offer is 30% equity in our company for 5.5 million sum. To note, this will be stage-gated and will be allocated for us to use based on predetermined milestones. And the sum will be used as shown now, driving the entire development process together.
Sorry, the time is up, so just 1 sentence.
Let's revolutionize AKI together.
Thanks a lot, Team Twente. Let's see what type of questions we have for you. Any fellow jury members that would like to kick off? If not, then I can start. I'm a bit puzzled about how you plan to combine a licensing strategy with a market entry yourself. And I was wondering to what extent you're not creating your own competition that way. What do you have to say about that? How are those strategies complementary and synergistic rather than problematic?
Yes, thank you for your question. I can see that this can be seen as a double-edged sword. For this, initially, the plan is to stay afloat with the licensing strategy. So currently our devices, as shown, not really compatible for a user-friendly interface. So what we have is the sensor technology and its integration into the device. This will be licensed to companies where they can use this approach to target, for example, different diseases based on the same conception and using different biomarkers.
Will you then exclude your, in the licensing agreement, will you then exclude your focus or?
To an extent, yes, okay. But we know that to basically once a patent is filed, it takes over 1.5 years to reach actually the public. During this time, we will continue our development and we will strive to actually minimize the system overall. So by the time our competition would get to this strategy, we should be further ahead.
And then another question that I had is with this challenge of miniaturization, so you need to bring the big box you have now into a patch they can put on an arm. But I was wondering, in the beginning of your presentation, you mentioned you would be targeting ICU patients. So do you then really need that? Because it seems that you're focusing on a customer group that does not really require a very small device in order to create the required benefits. And then I was wondering, does it really, especially given the additional investments you need to make to reduce the size, is it worthwhile?
Yes, so this can be attractive for hospitals, since it would take less days to after the ICU would get reduced, the ICU time, and.
No, I think if you're talking about ICU time, then you're talking about the benefit. But I was thinking, is there a benefit in having a very small device if you consider the ICU market?
Because then you can make people go home and do the monitoring from home. And then you're not
okay, so
spending
it's
that
also,
many days in the ICU.
it's not just within the ICU that you would
No,
test
no,
them.
it's,
Okay.
the plan is to move away from the ICU setting,
Okay.
and then you can discharge people earlier,
Okay.
and they can be still monitored in the
Okay.
at
So
their
in
home.
that sense, you're different from Team Glass. since we
Yeah,
just saw-
exactly. That's
okay.
the main
Yeah.
difference. Maybe we didn't come
Okay,
across.
thanks.
But yeah.
To add a few points, we all know that healthcare, especially within the US, suffers from many lawsuits currently due to inadequate care of the patients. One case of which could be the development of AKI, because staff are short-handed and it's just not feasible to care for everyone perfectly. Our solution would allow the monitoring, at least of ICU patients, for creatinine from at home. So this would be implemented over the course of 30 days, which studies have shown to be at the highest risk. And this would allow it would be cheaper for hospitals, first of all. They can use their staff for other means and more critical cases, and allow the patient to be in their home.
Thank you very much for your presentation. I have a question. Actually, I had another question, but now that you mentioned that, so you can also support the ICU patients at home. I didn't get that because so they might not only be in ICU because of the missing measurement that you can provide. There's of course also other means. So how do you think that you can send them home from ICU? Only based on your sensor?
Because you can develop ICU after 30 days of this major surgery. So if ICU is the last thing that you need to take care of, and that's why you're keeping them in hospital, then these last days then will be done at home. This monitoring will be done at home, but only
okay.
when acute kidney injury is the last thing that you're.
Because normally I have rarely seen a patient from ICU being directly going home. Maybe there will be an intermediate step in just a less intensive care hospital beds, etc. So I was just wondering if you sent them right away from ICU.
No, we don't plan to remove the ICU, the post-operatory time.
Okay.
It's just reducing the overall.
Okay, but it was just an intermediate question. So actually, my question was related to the premium features that you offer, and I like that idea. So it's a common business model, but I could not really understand how that would work in your case.
Yes. If I can add just a sentence to the previous case, the release of the patient would be basically the decision of the leading practitioner. So they would decide whether the patient can resume at-home activities, and our device should help in their decision for this, at least in relation to AKI development as a risk factor.
Okay.
Yeah, and then, sorry, could you repeat your second question?
The second question was the premium features that you
Yes.
offer for premium clients.
Yes.
And I was not, I don't understand what could be a premium feature. Can you elaborate a little bit on that?
Yes. So since our main customer base will be hospitals itself, we would offer diagnostic, let's say, approaches that allow the mass of patients that are being monitored to synchronize the data, target trends, have predictions, have alarming systems on potential cases, whereby if the drop or the dip is too high or too common occurrence, as well as we can offer the hospital premium maintenance on the device itself, data analytics, and also access to early innovative features, which we plan to develop in addition to our device.
Okay, fantastic. I like that idea. Let's follow this path in our minds. Let's say you have now this predictive model. You have a premium client. So what can he do with this data? So it tells him, let's say it tells him, okay, in 1 week, or I don't know how long you predict, you will run into a critical level. What can he do with this information?
So this information will be communicated first and foremost to the practitioner that is monitoring the person. Our system would signal potential cases that are of high risk. Then they could address or get in contact with them to warn them of this high risk and to implement different strategies to avoid basically development AKI, which is the whole purpose of the device in its own.
So I was more thinking in the direction, of course, the very critical cases needs to go to a specific practitioner, of course. But let's say so the long-term goal is that you maintain them that you have a kind of a therapeutic window where they can maintain them in. And so will you give just simply speaking, will you give them advice in nutrients they should eat, or will you give advice in specific medication they should avoid? So how can I understand that?
Yes, this would combine, again, the medication which they're currently under, which would interact with also the advice for the nutrition they should get, along with any rehabilitation that they're going, because depending on the ICU case, it's individualized. So there's many things to account for. So ideally, each person should be assigned to a different, well, not practitioner, but whoever should look after them while this monitoring process occurs. Our device should raise an alarm or just make their focus go into the individual case to have it at close monitoring. Then they would be able to analyze the current issues, current prescriptions, and offer possible window to avoid reaching the critical case.
So how would it work for a patient who goes home with it? Do you have an app where you can see it and inform your doctor, or are you just sitting there with, okay, my doctor wants me to still wear this at home, and he'll call me when I'm almost dead? I'm sure there's something in between there too, but so how would you do that with patients?
Yeah. So hopefully we'll outsource the development during the next 5 years, and we will transform this device into a smart patch system. The patient will be able to have something similar where they can monitor the situation, and they would be able to also get notifications from their practitioner. This technology could also be integrated as an application depending on the type of device that they use. And from their side, it would act like similar to a glucose sensor. They would log into their application, they would see their values, their trends, and of course, any communication based on the doctor.
Okay, thank you.
Thank you.
I think the time is up for the discussion. Yeah, thank you, guys.
Thank you.
Oh, yeah. Yes, and I would like to introduce Sense. Thank you. Imagine waking up with a knot of fear in your stomach. This is the life of kidney disease patient. Kidney disease is a silent killer. As a patient, you live with the constant fear that your condition could worsen at any time. And even worse, that this progression goes unnoticed. Traditional monitoring methods, such as point of care or blood checkup, can only be done every few months. Moreover, they are inconvenient and not easy to access, often requiring a trip to the hospital. This is where Sense step in. Let us introduce you Acria. Acria is a groundbreaking biosensor that empowers patients and make their life easier. With a small patch attached to your arm, you can continuously monitor creatinine for 2 weeks. Acria is not just another medical device. It's, as I said, a groundbreaking device, specially designed for kidney disease patients. Small yet powerful, Acria seamlessly integrated into your life. It's offering you real-time monitoring of your creatine level. This data-driven management approach enables both healthcare provider and patients with actionable insights, such as optimizing medication intake. Also, with its long shelf life, you can easily store Acria at home, making it available whenever you need it. With this, Acria permits you to control your creatine level at any time from anywhere. Our target patients are mainly chronic kidney disease patients and kidney transplant receiver. Acria offers them the freedom to live without the fear of the unknown. Additionally, it's perfect for patients suspected of AKI
and patients on nephrotoxic drugs. They can have information and actively, proactively even, manage their health. Our sales model works that patients purchase Acquia for €60 for 15 days. In exchange, they receive the device and full support, app access, maintenance, and customer support service. Also, the price is competitive, and it's based on production cost of €18 and additional costs such as R&D and certification. And also, we plan to implement a recycling program, reducing our environmental impact and our cost. With patient in the center, we will collaborate with both insurance company to ensure that Acquia is available for the one who need it the most, while reducing overall healthcare cost. We would also partner with healthcare provider to give recommendation and advice to the patients. To achieve this, our goal is to reach that 5% of kidney transplant recipients and 0.3% of CKD patients in Europe will receive this device in 20 years. This amount of 100,000 patients by 2045. We will start by securing funding to fund our R&D, and aiming for preclinical testing by 2028. The following year, we will start with regulatory certification. Given that Acquia is a Class 2B devices, we will also focus on our supply chain to make sure that everything fulfills the regulatory needed. By 2030, we will enter the German market and then expanding to Europe and eventually globally. We would reach break-even by 2032. Acquia, to find with a silent disease, give a voice to your kidney. Thank you to Vivines, the Uniclinic Collective Incubator, and thank you for listening.
Okay, thanks a lot. Yeah, everyone can step forward from Team Xsense if they want to jump in to address our questions. Let's have a look at my fellow. You would like to start?
Yeah, hi, thanks for your presentation. You were saying that you can monitor it whenever you want. Is the idea that you're just, if you're a CKD patient, that you just get a prescription for your doctor and always wear it? Or is the idea that you can just, once in a while when you're worried, wear it for a little while? And or what? How do you think you'll implement that for patients?
I think it will really depend on the doctor recommendation. That would always be the first one to look at. The goal is so we mainly target people from CKI of level 4. So those are the people who still are not at the hospital, but who are really where kidney failure can happen really quickly. And so those should wear it in our ideal ward all the time, but of course with the approval of the doctor.
Okay, thank you.
Can I ask a question? Thank you for your presentation. What I liked is that you indicated a target market share that you're aiming for. I was also wondering, do you have a strategy on how you're going to claim your position within the market, also with respect to other competitors in the field, as being a new company?
Do I understand correctly? You mean how what is the market strategy?
How are you going to promote yourself to claim that position in the market among existing products?
I think the first goal is really to partner with insurance company, because once also this device can be reimbursed by insurance, it's easier to promote it, and then to partner with hospital or nephrologist as our selling channel.
One small follow-up question. If you're partnering with health insurers, do you understand what would be their incentive? Do you have, what is your value proposition towards them to motivate them to come on board?
Chronic kidney disease is one of the most expensive diseases generally for our healthcare system. And so being able to have an early detection of when there's a problem is one point. And also, with our conversation with the nephrologist, we got that having a constant indication of the monitoring the creatinine level gives intake about which medication should the patient take. And being able to optimize the medication intake of the patients would also be more a value point for the insurance company, meaning they will not overspend medication who are not maybe useful or who could worsen the patients.
All right. Thanks for your presentation. I have a question, and I was a little bit. First of all, great pitch. But I was a little bit shocked by the 20 years to reach your market share. So you have announced that, and I was like, oof, 20 years. That's quite a forecast, very far in the future. I mean, I like to look so much in the future, and I can also imagine that you might reach it. But if I got you right, you will have around 100,000 patients, you said, no? In this case. And what is then the profit that you make from this 100,000 patients?
So, as I said, the production cost of one device is 18 euros, and then additional cost is R&D certification. So, if I remember, it also then depends of what is the percentage that the marketing channel would use, and also the channel one. I think I base my calculation on a profit of. So I guess, wait, I can show you this. It's probably better. So it's a net profit, if I remember well, of, as you can kind of see on the bulk, of 30%.
So, and what is what can you reach there? This is then 10 million, yeah?
Yeah.
This is then the revenue, or is that already the profit?
So the
profit.
revenue is
Okay.
the gross profit, and net profit is yeah.
Okay.
Revenue is the bulk, the blue bulk you see.
Okay. Just I find it a very for investor it might be hard to digest, not to wait for 20 years to have then the profit, which is good, 10 million. But one thing is it that it might be a very honest, let's say, proposition, but maybe you need to tailor it a little bit more to make it a little better digestible for an investor. And another thing is that in 20 years, so many things can happen, you know, so much. So this is maybe this forecast is very linearly thought, and there might be some big breakthroughs on the way there. So therefore, the second thing that I was also getting a little bit that was one thing that came to my mind when I thought this big number of 20 years forecast, which is very hard to stick to.
I think the idea between this 20-year forecast is, as you see, it's really a high number of patients, and it would be unrealistic to think that we reach 100,000 patients in 2 years after the market launch. So this is the idea between those 20 years. But of course, we're already profitable, you see, way before. So even if I get that these 20 years could look fearful in a certain way, it's look like we look in the long term, and we're already making profit earlier.
Okay, perfect. Then another question that was more related to the device itself. In the picture that you showed on the second slide, I think it seemed to be quite a massive needle that that you have to stick into your arm, and maybe that's just a matter of the resolution of the picture, or maybe of the because there's maybe no scale bar. But what needle size are you actually using here?
No, so right now we have a prototype who's more kind of a point-of-care devices, and this need to be moved to a on-the-body device, and so either integration with microarray of needle or an array, and so this is more for presentation purpose, let's say. Of course, it would, at the end, our main inspiration was of course the glucose continuous sensor, and we would go more in such direction where, of course, the patient doesn't feel pain or whatever when you use it.
Okay, thank you very much.
Yeah, just a short following question. Yeah, so how do you plan to differentiate your product from the competitive, let's say, the existing point-of-care devices?
So, wait. So, per measurement, we in every case cheaper. This is one of the main points. So the main one who exists right now in Europe are only just point of care. There's no continuous device. So first, the product just doesn't exist. So it's hard to really see the direct competitor. And then we look at the price, of course, just per strip. So you see here we are around €6 for the stat sensor. We are around 13 euros for the iSet. And for the large one, we don't even have a cost, but we are still cheaper per measurement. So this is one of the main arguments we can use, and also it just doesn't exist. Continuous pulse not possible, at least in Europe.
Yeah, I have a question about your investors or investments as well that you need. I saw on the slide that you showed earlier that you would like to have quite a big initial investment, and then a few years later a smaller one. What is the reason why you would like to go with a very big one in the beginning? Because a typical way of investing would be like have a seed round, an A, B, and C round.
Yeah. So first, this is a funding, for example, where also all of our employees get paid. We know if a startup, for example, if the 15 of us would start a startup, that would not be the case in the beginning. So this is also quite a, let's say, idealistic estimation. And so the second round of funding is to kind of sponsor, to fund the going onto the markets, and so the cost of the materials and everything. Sorry, no, I forgot the second part of your question.
Well, my main question was, why would you like to have a very big investment at the beginning, and why not spread it out a bit more?
Because generally investors would guess want to have a plan in 10 years maximum. They want to be profitable. And so the goal is to make the research and the R&D as quickly as possible. And this needs to be sponsored by money. So of course it could be shared onto different years. It doesn't need to be everything in the first year. But large amounts are needed in the beginning to make sure that R&D is as quick as possible. That's the reason.
Thank you.
The market share slide that you had earlier, which what you were hoping, I noticed that you actually, with the CKD level 5, you have a much smaller percentage you'd like than higher. Why is that? Because in general, if you're at level 5, that's the moment where every day it can change. That's the moment when suddenly you go from walking around and doing everything you want to, now I need dialysis today.
Okay, from what I understood with the interview with the doctors, there was that level 5 is typically already at the hospital or under such monitoring that it was a question. But this is clearly, I mean, a point of view, and they would need further research if the case at level 5 are still not at the hospital.
Okay, yeah. I'm kidney patient myself, and it's when you're at level 5, yes, you're at the hospital very often, but it's often indeed to get this checked. So that's why I figured. So that's a tip then.
Yeah, thank you very much for the tip.
Time for the discussion is up. So thank you.
Yeah.
Hello, everyone.
Now it's UC team.
Right, before we start, can I just see a quick show of hands? Who here has a smartwatch or a health-related app on their phone? All right, that's a promising start already. Okay, so without any further ado, my name is Daniel, and today I'm going to present you the translation potential pitch of UC team, a group of 13 ambitious students from Prague. Imagine a world where monitoring your kidney health is as easy as monitoring your fitness metrics. Nowadays, with kidney-related problems becoming increasingly more prevalent within our society, the need for an accessible and preventive monitoring device has never been higher. Introducing KidneyGuard, a revolutionary step towards personalized healthcare. As of today, the most common method to determine one's creatinine level and overall kidney health is through the so-called Jaffe method. This method is not only non-specific, but it also is very hard to reproduce in between laboratories, and furthermore does not provide us with creatinine levels or trends. We aim to alleviate those limitations with our biosensor KidneyGuard. With KidneyGuard, we aim to provide real-time monitoring of creatinine trends, which can be integrated into an app, and providing correlations with patients' health, well, with his health, obviously, but with his medication, physical activity, or diet. Furthermore, this can help doctors prevent disease progression, optimize dialysis, and overall improve the patient's quality of life. Furthermore, we can also assist doctors to decide on further testing, reduce blood tests, and reduce hospital visits, both of which are especially debilitating to already weakened patients, for example, kidney transplants and such. In terms of our business plan, we initially aim to target hospitals and health centers, whom we would like to equip with a biosensor with a displaying device. Secondly, we will target other groups, but our main priority and key to our success is our close cooperation with insurance companies, who will be responsible for the coverage and reimbursement of our biosensor. As of now, we are in the research phase, where we currently focus on fine-tuning and miniaturization of our biosensor. However, by 2027, we would like to enter preclinical and clinical trials with our already established partners, who not only have valuable research experience, but also have testing sites and hospitals at their disposal. Furthermore, after obtaining all the necessary licensing, we would like to launch KidneyGuard in 2035 on the Czech market. From there, we would like to expand to Germany and Scandinavian countries, with the perspective of expansion to the whole of Europe by 2040. As of now, the prototype cost is set at 221 euros. However, we foresee the cost reduction to 67 euros when we enter manufacturing. Based on this and based on the variable cost of the biosensor and our market research, we decided to set the price for the biosensor at 89 euros for a biosensor which have data integrated into an app, and at 109 euros for a biosensor with a displaying device for the hospitals. This way, we calculated that we need to sell 31,345 devices annually to reach break even. Lastly, I would like to thank our sponsors, without whom our scientific journey wouldn't have been possible. So thank you, and thank you for listening.
Okay, thanks a lot, UC team, for this presentation. Any questions from my fellow jury members to start with? Okay, then I don't always want to start, but let's see. So I think based on your pitch, we saw on the one hand you have this long-term vision of what you want to accomplish in terms of kidney health, and then you showed your roadmap or path towards that. Let me start with the end, like the end goal of launching KidneyGuard as a monitoring advice that is used by the wide population. I would say that also requires building some awareness. So where I'm at now, as a person speaking, I wouldn't care too much about tracking my kidney. So how do you plan to do so? What is your incentive? What incentive do you see for the broad population to start doing that?
Okay, I don't know if it was completely clear, but obviously initially we would like to target kidney patients mostly, who, as has been already mentioned many times, will be found in hospitals, either at nephrology departments or even at ICUs, as as AKI is a very common thing to happen after either surgeries or medications with all sorts of pain-relieving medication. So obviously that's why we firstly want to target hospitals and medical professionals, who we also plan to sort of incorporate in our strategy in expanding, let's say, the use of KidneyGuard for the future. As for the regular patients, well, we also hope to give access to KidneyGuard through pharmacies and e-pharmacies in the future. And as we know, many people whom the doctors wouldn't necessarily find necessary for them to use such monitoring device are still interested in buying it. However, the difference is that for some patients, this device can actually be reimbursed based on the analysis that can be done along with the doctors. However, for regular patients, this device might not be reimbursed, and it's going to be only up to their let's say, judgment whether they use it or not. And those reasons for them to use it there might be all sorts of them. It could be, used for kidney patients or someone who had kidney problems in the past. It could be for, let's say, sportsmen or competitive athletes who are looking to optimize their training, but it also could be for eventually for veterinary patients. So depends.
Yeah, but I think if you're trying to do too much, it becomes a bit unclear what
For
exactly
sure.
you're trying to solve. So if we go back to the hospitals,
Yep.
what is it that you solve for them and their patients? So where to start within those hospitals, targeting a particular patient population? Can you elaborate a bit more on that?
For sure. So as I already said, we're going to focus mainly on AKI patients. Also, the chronic kidney patients who are in the late stages of their disease.
Okay, and what does that mean for testing policy within a hospital setting? So what, what type of patients within the hospital are being monitored?
Yes, so based on our meetings, we identified that it's beneficial for them to monitor the patients that are undergoing dialysis, but also patients that are on gene therapy or oncology treatment, as kidney is one of the first vital organs to show damage and progress to AKI.
Okay, but then you have, I'm now trying to understand, you then have different decision makers, because if it's an oncology patient, perhaps you need to convince the oncologist to start monitoring them versus patients that are on dialysis. So would it require convincing different specialists? How should I envision that?
Yes, it would require that.
Okay.
We've been in close contact with nephrology experts, and also we're planning to get into contact with oncology doctors and gene therapy doctors.
Okay. Any follow-up questions or other questions from my jury colleagues? And then we can move to policy.
So how flexible is your pricing strategy? Because I saw you make a very clear price for the device. And
yeah, so as of now, the prototype has a really big price, and 80% of the price comprises of the enzymes. So we're looking into our own biotechnological production of these enzymes and regeneration in order to reduce the costs of the device. We've also established a bulk order, let's say, manufacturing tools that we will order from China, and the potential cells will be assembled in-house. We've been also in close contact with our SPC producer, and they're said to be able to provide 100,000 SPCs daily.
yeah, okay, thanks. Yeah.
I have a question about the price as well, and especially about the gross margin. Because your future cost, you predict like 67 euro, and end user price is 89. And you think if you sell a bit more, like 30,000 devices, you'll be at your break-even point. And I was positively surprised by that small difference. How do you make sure you actually be break-even at that when selling 30,000 units? How do you make that such a low number?
So yes, the number 31,000 units would mean that each patient would be monitored for 3 to 4 months annually, which means around 2,500 patients would be monitored on the device per year. Based on our global report data we obtained, the number of patients that needs the monitoring are way, way higher, roughly tens or even 100 tens of thousands annually. So the break-even point can be even lower.
Okay, well, that's quite positive. Thank you.
Sorry, on one of the first slides, so I don't have a biomedical background. You made a comparison to other technologies as well. I'm not familiar with those technologies, but could you walk me through that comparison shortly?
Sure. So the Jaffe method is the most common method used in hospitals. It requires a colorimetric reaction. The main advantage of this method is that it's extremely cheap. However, the problem arises when, first of all, it has a certain level of inaccuracy. Secondly, it's also very hard to reproduce and to get the same results in between two labs. So that according what the specialists that we talked to shared with us, the main problem is that when they get the results for the same patient or for the same sample from two different laboratories, the creatinine levels are just different. And the problem is also that the limiting concentrations can be different, like based on those labs. Like one concentration can be a problem there, and then you have a different concentration there, which can be a problem at a different laboratory, essentially. And if I may elaborate further on this, like there's many kinds of possible analytics that you can do with creatinine, but essentially this is the most common one. And then like you have obviously like the most precise technologies that include HPLCs and IDMS. However, those are extremely expensive, like when it comes to use in medical environment. So there's no really practical way of implementing that.
Can you tell me what makes them? Because I'm not familiar with that.
Yeah. So well, basically, mainly the instrumentation is very expensive to buy, and then also you would have to have a long you would have to instruct the person who would be running the analysis for them, and it's I would say a little more challenging than, for example, the Jaffe method.
And that would be the most relevant competitors for the market that you're targeting.
Well, for the market, for the market that we're targeting, what we're essentially saying is that we're gonna save time and save the amount, or save money in the amount of tests that will be necessary to be done. However, we still need more data when it comes to saving time for the nurses and for the hospital staff. But it's something that they might want to look into, especially the private hospitals or private hospital sector.
Yeah, so just to add, there's also a big company that has very similar patent to ours, which is the Able Laboratories. However, this patent has been declined already 5 times, so we are not at the moment concerned about that.
Okay.
The time is up, but there's just one last question. Very shortly.
A very small question. Did you account for the costs of the clinical trials in your break-even point? And what is the estimated cost for the clinical trials?
Yes, so the estimated costs of the clinical trials are based on the continuous glucose monitoring device, which is on the internet. We've calculated based on this analysis that the cost would be roughly 2.5 million euros. And we've also been in close contact with Czech companies already established for preclinical and clinical trials, and we've also already received a confidential document offer for preclinical trials, where there's all necessary details in it, like costs, the procedures done, and many others.
Thank you.
So, thank you. And this is the end of round 2. So great job, everyone, and enjoy the rest of the day.